Hello everyone, I welcome you all in the Engineering Graphics lecture series. Friends, in this session, we are going to solve a problem from Engineering Graphics question paper. This is previous year question paper, and in this lecture, we are going to solve a problem number 1. So the problem statement is the endpoint P of a line PQ is 25 mm above HP, while its point Q is 15 mm in front of VP. Its plan and elevation makes 40° and 35° with XY respectively. Draw the projections if the projector distance between the end points is 60 mm. Find inclination made by the line with HP and VP. So the weightage of this problem is 12 marks. So from problem statement, we can write down the given data. So end point P of a line PQ is given. So point P is 25 mm above HP, while its end point Q, the line end point Q is 15 mm in front of VP. Point Q is in front of VP. Its plan and elevation makes 40 and 35°. We know that plan makes beta angle and elevation makes alpha angle with XY plane. So plan length angle is beta, this is 40° and alpha is equal to 35° respectively. Draw the projections if the projector distance between the end point is 60 mm. So projector distance is given in this problem and it is 60 mm. So this is the given data, and find the inclination made by the line with HP and VP means the meaning of this last sentence is we have to find a theta angle and phi angle for this problem. So this is very simple problem. So see the solution. So we can mark point P dash first. Draw a XY reference line. This is X, Y. Now mark point P, it is 25 mm above HP, so we can locate point P above XY. So above XY, mark a point P locus line. So on this line, we can mark a point P dash. This is a locus of P dash. On this line, we can mark point P. Also Q is given, Q point is given, it is 15 mm in front of PP. So below XY, we can mark a locus of Q. So draw the straight thin line. This is a locus of Q. On this locus P dash, mark a point P. So here is a point P, and from this draw the vertical line. So this is your point P dash. This is point P dash. Now in this problem, P point, only P dash point location is given, but P point location is not given. But Q locus is given in this problem. So after that, mark a alpha angle. Alpha is at 35°. This is a 35°. By using thin line, draw the 35° angle line. Projector distance is given, so from along XY, from projection of P, mark a 60 mm projector distance, and from this projector distance, draw the vertical line. So this vertical line and this alpha angle line intersect at a point Q dash. Now we can solve this problem very easily, but for that we required a reference diagram. So without reference diagram, we cannot solve this problem. So this is point P dash, this point is P, phi. This is a Q dash, Q1 dash, projection, rotation. This is a Q2, Q. This angle is alpha, this is beta. Now in this problem, now we can see the next step. From given data, you can find the elevation length. This length is called the elevation length, and this elevation length makes alpha angle with xy axis. Now here, from this projection, now here is the intersection point of locus of q and vertical position of q dash. So here we get a point q. So from this point q we can draw a beta degree angle. So beta degree angle is given in this problem. It is 40 degree. So along this direction, along anti-clockwise direction, mark a 45 degree angle. Mark a 40 degree angle and draw a beta angle line. This is called as a plan length. This is a plan length. This angle is a beta angle, and this beta angle line intersect the projection of P dash at a point P. Now after that, so we have the elevation length. You can see here, I'll get a P point. So from P dash, we can draw a locus line. So this is a locus of P. Also we can draw a locus of Q dash. Locus of Q dash. Now you can see here we have the elevation length. If you rotate elevation length up to locus of P dash, and then if we project up to locus of Q, we will get a true length. This is a true length, and directly we get a phi angle. So take a rounder. From P dash, measure this elevation length distance in a compass and mark a arc up to locus of P dash, and then project this point up to locus of Q. So here I'll get a Q2 point. This point is Q2 dash. Now if you join P and Q2, directly we'll get a true length, and this angle is a phi angle. Now we have the true length distance. So measure this true length distance in a compass and mark this true length distance in a front view. So here is a Q1 dash point. Now if you join P dash and Q dash, I'll get a true length. This true length makes theta angle. Now that's the complete solution of this problem. Mark the dimensions. So here locus or point P and Q dimension is given. So show this dimension. So this is a 15 mm. This is a 25 mm. Now find the answers. Now here find a theta and phi angle. So theta angle is 27 degree and phi angle is 40 degree. Measure the elevation length distance. Nearly 74 mm. True length is 94 and plan length is 85. So this is a plan length. Now you can see the solution of this problem. Number 1. Try to solve this problem. Thanks for watching this video.